Hi guys, in this video we're going to continue working with the topic of magnetism. What we're going to do in this video is we're going to try to analyze and explain a little bit more about the interactions between magnets and how these magnets interact with the magnetic field on Earth and how the compass work. And this is what we're going to do. Like always, take notes in your notebook of everything that are going to be explaining and everything that will be in the document, and then take a picture and upload the picture to Google Classroom. Okay, we're going to start first with magnetic field. Now, here in this picture that I have in the document, we can see how we have a magnet right here in the center, and then you can see all these loops of that are around the magnet. This is iron filling. This is iron that they try to cut as small as possible, and then when they throw all these small pieces of iron over a piece of paper, we are going to see these loops around the magnet. This is something that I'm going to do in about 30 to 40 seconds, and you're going to see how this works. That's me, don't worry. Now, let's explain first what is happening here. Now, first is the iron fillings align with the magnetic field of the bar magnet. We can see how these iron fillings are aligning with the magnetic field around the magnet. Second, the magnetic field moves from one pole to the other pole of the magnet, creating a closed loop. We can see also here how these loops between one corner to the other one are a closed loop, since they go from one side and then they finish in the other side. Always is going to be a closed loop. Okay, here I have a paper. Below this paper we have a bar magnet. Now, also in my hand I have iron filling. Now this is the iron that is cut in really small pieces. Now I'm going to start throwing this iron filling over the paper, and you are going to see what is going to happen. Now right now you can see really fast how we are trying to see in the loops that I explained a few seconds ago, how they are connecting from one corner to the other corner. Now, let's see right here. We can see right here that we have one corner of the magnet. Here we have the other corner of the magnet, and then also we can see right here the closed loops from one side to the other side. Yeah? Always we have this closed loop. Now, something else that we can see is in the corners, the lines are really more close compared when you go far from the poles, yeah, the north or the south. That means that when we are close to the poles, the magnetic field is going to be stronger. See right here, yeah? Right here is stronger, right here is stronger. Now, trying to review, here we can see the closed loops between the corner of the magnet, and then this corner of the magnet or the pole, the magnetic field is stronger, since the lines are closer one to the other one. After the demonstration that you saw how the magnetic field is around the magnet, now we're going to try to specify a little bit more about this magnetic field. Now, this magnetic line leave the north pole of the magnet and enter the south pole of the magnet. As we can see right here below, we got this magnet right here, and all these vectors that are the magnetic field are going out from the north, and then they finish on the south. Now, always they're going from the north to the south. Okay? Now, you see we have like 8 to 10 different lines, magnetic lines, that all of them are starting in one corner and finishing the other corner. Now, in all this area around the poles, we can see like the distance between the lines is smaller compared to right here, that we can see that they are more far away from each other. Now, what that means is that when these lines are closer to each other, the magnetic field is going to be stronger. Okay? That's something that you need to remember. Something else is that always this line, I know that here we can see that they are open. They are not really open. They are going from one corner to the other corner, going from the north to the south. Continue working with the magnetic field, we can see that different configurations of magnet will produce interesting magnetic field. Now, see right here, I have here two different interaction between magnets. In the first one, that is in the top one, we have the north and the south. They are interacting. Now, one thing that we need to see is that all these lines are going from north to the south, exactly how I explained about 20 seconds ago, from the north to the south. But between the magnets, we can see right here that it's like a bridge. This bridge means that the connection between the north and the south is creating this bridge that you can see now. This line connecting from one magnet to the other magnet mean that they're creating a attraction force. Okay, now why we have an attraction force? Since these two poles are opposite. I mean, when we have different poles like north and south, is when we are going to see these lines right here, like this one, and this is going to create an attraction force. Now, going below, now we have that these two magnets, the poles are exactly the same. Here we have north, here we have north. Now, see what happened. First point that you need to see, always lines going from north to south, north to south. But now here I cannot see a bridge. I see like walls. You can see this line going up in each side of the magnet, and then they're creating like a wall in the center. This wall is what creates this force. They repel each other, and that's why when you try to put together two magnets using the same side, you can feel this force that is pushing your arm. Don't let you put these two magnets together. That's why we can see all this line trying to get in a wall between them. Okay, now let's see this example. Okay. Here we can see the interaction between two magnets. Here I have one magnet, here I have the other one. Now we can see that first we can see the loops between the corner of the magnet, creating a closed loop. Here the first one, here the second one. But then also between them, we can see here the bridge. Now this bridge right here means that we have an attraction force. Since we can see all this loop in the center and then the bridge in exactly between them, that means that we have attraction force, and if we have attraction force, that also means that these two corners right here are opposite. They need to be north and south, since we have the connection between them. And remember, right here we have attraction force. Now we go here on the right, we have another interaction. Now here we have a magnet. We can see the poles and we can see the loops, and then here also we can see another magnet. When we can see right here all the loops, they are closed. Now between these two magnets, now in the center is empty, and then if you go a little bit to the right and to the left, we can see all these lines that are exactly straight. All these lines that are exactly straight is the magnetic field that is fighting one line with the other line, creating a repulsion force. They're repelling each other. They don't want to be together. And this is what we can see right here. Then if we analyze this image and with the concept that I explained 2 minutes ago, right here, these two poles They need to be exactly the same. And that's why they don't want to be together. Going more deeper with interaction, something that we need to know is what is the Earth magnetic field. Now, a magnetic field is really similar to a barrier magnet. Now, if we can see here in this image, we can see that we have here the Earth and we have here the barrier magnet. Now, how this work? How we have a magnetic field on a planet? Now, you know why? Because the planet, it have a center, the core nucleus of the Earth is iron, and this iron is molten. I mean, it's like liquid. Now, the circulation of this liquid of iron that are in the outer core of the nucleus is what is creating this magnetic field that the Earth have. Now, this magnetic field is not exactly how we are thinking. On the north of the Earth, we have the south magnetic field. Now, in the south of Earth, we have the north magnetic field. That means it's opposite. That's something that you need to remember. Where is the geographic North Pole is really the south magnetic pole. Okay. Now, these magnetic poles are not located along exactly the Earth axis of rotation. If we see right here, this is how the Earth is rotating all the time, but the magnetic field is a little bit is going like flipping to one side. That means that it's not exactly in the center. How we can use this magnetic field of Earth? Using the compass. The magnetic compass was an important advantage in navigation. Now, why? This allowed mariners to determine their direction even when it was impossible to see the stars. These guys that they were traveling from one point to another point, they were using the stars to be able to know the direction that they were moving, and then this will help them to be able to go as fast as possible. Now, sometimes we have clouds. Now, this cloud, it will block the view to see where what the North Star. Now, they start using this compass. Since this compass have a magnetic needle that can turn freely, so that always point to the North Pole of Earth. That means that you will know exactly in what direction are you going if you learn how to use this compass. That's why this was really, really important. An example is if they normally took 3 days traveling from one point to another point, with the compass, the travel was only 1 day. That means it cut the time by 3. I mean, this helped a lot. Navigation and how society right now is evolving thanks to the magnetic compass that was being used for the past like 600 years. This magnetic field of Earth is not only in the nucleus or in the surface of Earth, it also go to atmosphere. And then we can see right here, this is this image that we have on top. This is not real, it's only to try for you to understand the concept. This is the magnetic field, that is the blue side. Now, here we have also the sun. Now, the sun have a core that is really powerful and is always irradiating, is throwing electron and proton and plasma really fast to the Earth. And now this is why you can see this wall right here and this one, the blue and the orange, that they have a collision. But this is why we can see right here this image that I think look amazing. Now, the last one, the interaction between all these electrons and protons that are coming from the sun with the magnetic field of Earth create the aurora borealis. The aurora borealis is all the interaction between all these electrons and protons from the sun that have been traveling really fast to Earth with the atmosphere in the north of the earth is what is creating these colors, normally like green or blue on the sky that we can see right here in this picture that are amazing. This picture right here is real. And now in this one we can see how the interaction between the sun and the atmosphere with the magnetic field of earth can create something so crazy like this one. Remember to take note everything that I wrote. You need to write in your notebook, take a picture, and then upload the picture to Google Classroom. Thank you. Have a good day.